Hi everyone, these are going to be notes for 8.2 day 1. We are starting a brand new section today as part of our Unit 8, and this section is all about radical and rational exponent notation. Those are both words that we'll know the meaning of by the time we're done with today's notes. But to start today's notes, we're actually going to work on filling out this table together. I'm going to start filling out the table and get some of the values that we need up, and then you can actually finish filling out the table on your own, and we will be using this table often as part of this section. So if we look at the start of it, notice the title, Numbers I Will Be Responsible For, fill in the non-shaded boxes. So if I start here, 1 squared, let me just get this all set. 1 squared is 1. 1 to the third means 1 times 1 times 1, that's still 1. 1 to the fourth is 1, and 1 to the fifth is 1. 2 to the second power is 4. 2 to the third power is 8. 2 to the fourth, so if we need help to see that, that's 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. Multiply that by 1 more 2, and I get to 32. So in other words, 2 to the fifth equals 32. 3 squared is 9. 3 to the third is 27, because 3 times 3 is 9, times 3 is 27. From here, we may need your calculator. So if you want to go grab it, now would be a good time, because we are going to do 3 to the fourth power, which means 1, 2, 3, 4. 4 3s multiplied together. You could think of it as 3 times 3 is 9, and 3 times 3 is 9. 9 times 9, 81. So 3 to the fourth power is 81. 3 to the fifth power, I'll give you a second to put that into your calculator. If you haven't gotten your calculator, please press pause and go get it and figure out 3 to the fifth. I'll leave that box empty for you, and we'll check tomorrow what you got for 3 to the fifth. Here, 4 squared is 16. And then 4 to the third, 64. That came from 4 times 4 times 4, so 3 fours. And from here, I'm going to ask that you actually work to complete this chart. So please press pause, finish filling it out, and then we'll actually compare charts at the start of class tomorrow. So press pause, finish your chart, and then we'll compare. Once your chart is done, let's get into our notes. So that chart will be referenced throughout these notes. Notice we're going to be focusing on this word exponential and radical and the fact that they're the same. So there's a connection between these notations that we're going to learn about today. What is a square root? When we talk about square roots, we're actually determining what number times itself results in what you're taking the square root of. And root is one word right here. Sorry about that. I'm actually not using my little tablet, I'm using the marker. The orientation's off a little bit, so root is that word right there. So you're determining what number times itself results in what you're taking the square root of. Another connection to an actual square root is the side length. So for example, if I look at number 1 here, it says the square root of 36. Well, if this square had area 36, if I asked you what the side length is, the side length is 6, because 6 times 6 is 36. So the square root of 36 equals 6, because 6 squared equals 36. Another little point to elevate our knowledge of square roots, it's called a square root because there is actually a little invisible 2 right there, but we never actually write that 2. When we see this symbol, which is actually called a radical, this radical symbol, it's assumed that we're talking square roots when you do not see a number there. That's why we've always called it square root, all through Algebra 1. But now that we're in Algebra 2, we want, again, to raise our understanding of what that symbol means. The square root of 121, I'm hoping we remember from our 9th grade perfect square days. Square root of 121 is 11. What's the square root of 64? Square root of 64 is 8, because 8 times 8 is 64. And then last but not least, square root of -9. Can I take the square root of a negative number? No, I can't. This is no solution. No solution. Bear with me, guys. No solution. Because if I square 3, I get 9. If I square -3, I still get 9. There's no number that you can square that will arrive at a negative value. So when we say we can't take the square root of a negative number, that's why, and we will always write no solution for the square root of a negative. So now that we have our brains warmed up, because questions 1 through 4 all come from our Algebra 1 knowledge, let's move a little deeper. We have a statement here to fill in. You can evaluate other roots in radical notation. Radical notation, use our highlighter to make this stand out. That is called radical notation when we see that symbol, where n is the root. Also known as index. We will use the word root. So coming back to our examples in 1 through 4, these were all the square root that we were working with. But there's not just square root possible. If we start looking at numbers 5 through 12, we'll observe that. Notice all of those other little numbers. In number 5, I see that I am not taking the square root. I see that I am taking the third root. In number 6, fourth root. Number 8, fifth root. So let's see how this is going to work. The directions say evaluate the nth root, because here the numbers are changing. Third root, fourth root, fifth root. Well, how are we going to do that? And here it says use your calculator, charts, or mental math. We're going to focus on using our chart and mental math. So for number 5, when it says third root of 8, I would like you to write this note. what number times itself 3 times equals 8. That's really what that means. When you're asked to evaluate the third root of 8, what number times itself 3 times equals 8? In other words, what number, like if I drew an empty little box, to the third equals 8? Well, if we go look at our chart, some of you may be thinking of the answer in your head right now, but let me show you how the chart works. So I go back to my chart. We're looking at power, the third power column right here. And I look, oh, look, there's 8. Now I look to the left, the answer is 2. So again, I was being asked to evaluate a third root. So I go back to my chart and I look in that power, the third power column. I find that value 8 and I look to the left and it's 2. So the answer is 2 because 2 to the third equals 8. Now, in the same way last year that you became more familiar with your perfect squares, we don't just have perfect squares. Looking at your chart again, these are going to be all your perfect squares. These are your perfect cubes, or third power, perfect fourths, perfect fifth power. So in Algebra 1, you just dealt with perfect squares. And now we have 3 new columns that we will be learning and be responsible for. Remember, you're not going to be accountable for anything in gray. Perfect thirds, fourths, and fifths. So 8 is a perfect cube because the cube root of 8 is 2. Let's practice some more. Number 6. Out loud, I would say the fourth root of 81. What is the fourth root of 81? What number times itself 4 times is 81? So please think, what column am I going to go look at? Well, I see fourth root, so I'm going to go to the x to the fourth column, and I look, there's 81. 3 is the answer. The answer is 3. Because 3 to the fourth equals 81. 3 times 3 is 9, times 3 is 27, times 3 is 81. Fourth root of 81 is 3. Third root of 64. Try that one on your own. See if you can go use your chart or your mental math. What number times itself 3 times is 64? I go to my chart. I am looking at the x to the third column. Here's 64. I go to the left. The answer is 4. Because 4 to the third power is 64. I'll say that again. 4 to the third power is 64. Let's do one more together. Number 8, the fifth root of 32. What number times itself 5 times is 32? Use your chart. Press pause if you need to for a second. So what I'm hoping you just did is on your chart, I see that I'm taking the fifth root. So I go to my chart, I go to x to the fifth column. There's 32. I look left, 2 is the answer because 2 to the fifth equals 32. I'm going to leave 9 through 12 for you to do on your own. And I'll check those first thing tomorrow with you. So pause right now, use your chart to work on 9 through 12, and when you're done, join me back for the notes. And again, I'll check those with you at first thing tomorrow. Continuing with the notes, let's read what it says here. The root of a number can also be written in rational exponent notation. Let's highlight that. Rational exponent notation, which is read a to the 1/nth power. Or I know we'll probably kind of fight a battle of not saying 1 over n. I want us to avoid saying 1 over n and reading that as a fraction. In this case, 1/nth, where n is the root and 1 is the power. So this right here is super important. This is how the notations match up to each other. I could actually help myself out even more and put a little a to the 1 right there. So a to the 1/nth. These are equivalent. They mean the same thing. The best way to get comfortable with how we move between these two notations is to practice. So we have 9 here to practice. Again, I'll be doing roughly half with you, and then the other half will be for you to try, and we'll check in with each other. So let's start with 13. 16 to the 1/2. 16 to the 1/2. To the 1/2. Well, when I look at my definition, it says n is the roots. So when I look here, 16 to the 1/2, the denominator is the root. So I am actually taking the square root of 16 to the first power. But we don't ever really write the first power. So this is really just the square root of 16. I know the square root of 16 is 4, and I'm done. So whenever we're starting with this fraction as an exponent, you want to pay attention to the denominator first, because that is the root. So as soon as I see 16 to the 1/2, I read this as the square root of 16 to the first. The numerator is the power. If you notice, in all of these, look at the numerators. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. So for today's notes and new learning, we're really just more focusing on identifying the root. In the future, the numerator will not be 1. But for today, our focus will be on the root. So that being said, for number 14, what is the root? This was the square root of 16. This is the third root of 216. The third root of 216. Please go use your chart to find me the third root of 216. So I go to my chart, and your chart should be filled out because I need to find 216 in this column. A hint, it's going to be in this box. So I'll check this row with you. 6 squared is 36. 6 times 6 times 6, we should have gotten 216. In other words, 6 to the third equals 216. So the answer to that question, the third root of 216 equals 6. Because 6 times 6 times 6, 3 of them, multiplied together equals 216. Number 15, I am looking for the fifth root of 243. Again, we are paying attention to the denominator of the fraction because that tells us the root. N is the root. Fifth root of 243. 1 is the power. I don't want to leave that out too much. It's not our focus because 243 to the first power is just 243. Fifth root of 243 to the first, or just fifth root of 243. Go ahead and use your chart. So if I know I'm looking at the fifth root, when I go to my chart, I'm going to go to the x to the fifth column. If you have finished filling out your chart, 243 is right here. Which makes the answer what? What is the answer? The answer, because I go to 243 and I look to the left, is 3. If you struggle to fill in that box, it's 243 because 3 times 3 times 3 times 3 times 3. So that's 1, 2, 3, 5 threes equals 243. So the fifth root of 243 equals 3. That's our connection. No different than last year, where 3 squared was 9. So the square root of 9 is 3. This was Algebra 1. We're stepping it up. We're not just learning about square roots and raising to the second power. Now we're making the connection to fifth root and raising something to the fifth power. Knowing these numbers will just take time because, again, you are accountable for everything not in gray. So just like last year in 9th grade where you wrote your perfect squares over and over, I highly recommend making flashcards of these values because over the next couple of days, it will become a required knowledge that the fifth root of 243 is 3 or that 3 to the fifth power is 243. So what I just said out loud was this knowledge right here, knowing that the fifth root of 243 is 3 and 3 to the fifth equals 243. We have to memorize these numbers. Just like you're comfortable with your perfect squares, we're going to be comfortable with perfect thirds, fourths, fifths. Very exciting. This one, you have to have finished filling out your chart, so I'll leave that one for you. Let me see, is this one on your chart? It is. Okay, so I'll do number 17 with you. My question to you, what root am I taking? Well, I look at the denominator. As soon as I hear that word root, I know I am focusing on the denominator. So this is the fourth root of 81. I may know that already. If I don't, that's okay. It's our first day, so we're going to go use our chart. I find the x to the fourth column. I look for 81. There it is. Look left. 3 is the answer. Because 3 to the fourth equals 81. 18. Let's talk about 18. I'd be interested tomorrow to see what you put for 11 versus 12, because there is a difference between taking an odd root and an even root. This does exist. This does not. And I'm going to use number 18 to help us realize why. I'm pretty sure I'll probably help you find that on the chart too, because if I look, I don't think we have 512 on there yet. No, we don't. So I'll check that with you. Sorry for the flips back and forth. 18, negative 512 raised to the 1/3. If I say it right, 1/3, I know I am taking the third root. Do you hear that connection? Negative 512 raised to the 1/3, third root. What number times itself 3 times is 512? If we have filled out our chart correctly, we should get 8. But it's not going to be 8. The answer is negative 8. I can take the odd root of a negative number. I'm going to put a note down here. Negative 8 times negative 8 times negative 8 does equal negative 512. If I look, if I'm dealing with an odd number, this is going to be even, but you're always multiplying by one more negative. So here I had at the beginning, negative times negative is positive. Multiplied by one more negative is negative. So this does exist. Negative 8 to the third is negative 512. So odd roots, I can take the odd root of a negative. I cannot take the even root of a negative. So looking at number 21, that would be the square root of negative 4. That's not okay. That is no solution. So I'm actually going to highlight this to make it stand out. This, that's okay. That had an answer. I can take the odd root of a negative. This was no solution because I cannot take the even root of a negative. Odd root, yes. Even root, no. That will come with practice. I'm going to leave the rest for you to work on, and we'll check answers together tomorrow on those. My hints for 22 and 23, both of those are possible. Leave the negative on the outside. So for 22 and 23, just leave the negative on the outside. Your job is to figure out what number goes here and what number goes here. So to summarize, what radical notation is versus rational exponent notation. Radical, I want you to think of our symbol, that square root symbol that we've written so many times, but we're going to elevate what we write to not just be a random square root, it's the nth root of a, where we now know that we don't just have square roots. We don't just have square roots. We have fourth roots, we have third roots, we have fifth roots. So that's why we now have n involved, because we have more possibilities than just square root. Moving between radical and rational notation, remember that technically this is a to the first power. We just haven't been writing the power. Changing this power to be anything other than 1, that will come up later on. Today's focus is just on getting used to this idea of different roots. To rewrite from radical to rational notation, we say nth root. Because n is the root. And I would rewrite this as a to the 1 divided by n. In this notation, the denominator of the power, which is what we've been looking at this whole time, is what root you're taking. That's the big takeaway from the practice we just did. The denominator of the power is the root. So running through a couple just one more time, look where I'm pointing. Square root, third root, fifth root, third root, fourth root. In all of these, my eye immediately goes to the denominator first because that is my root. Okay. I'm going to end the notes with transferring what we just wrote at the bottom right here. So A, moving between notations, because this is ultimately our goal. A to the 1 nth, or 1 divided by n, becomes the nth root of A. What I just said, and I want to emphasize it, nth root. It's hard for me to make sure that you can hear the th. Nth root of A. There is a power involved, and that's where I'm going to end the notes. A to the first, technically. Nth root of A to the first power. That came out really wide, so I'm going to rewrite it so it fits. Nth root of A to the first power is what we're going to write here. Let me change the marker to be a little skinnier. Nth root of A to the first power is how you would read this out loud. We will start class tomorrow by first checking your answers for the rest of how you filled in this table. You trying 9 through 12 and these remaining couple. Once we have finished checking and comparing our answers together, in class tomorrow, I will continue these notes with you, which won't take us too long, but I want to make sure my video doesn't go past 35-ish minutes. So the rest of this conversation we'll have tomorrow, and then in class, we will work on this practice. So one more time, your job tonight, after you finish watching my video, is to go back, finish filling out this table if you did not already, and then give these a try. 9 through 12, and these 1, 2, 3, 4, 5. These last couple. We will finish these tomorrow and get to work on the practice. Great job today or tonight working on your homework and taking these notes. We will build on all this new learning tomorrow in class. Have a good night.